Hi guys, we are on Unit 3, Day 10. This is the last day of Day 10. It's our final day talking about your key features of our graph or our function. And in number 1, it says that the function y equals f of x is shown graph to the right, and they want to know the domain. So remember what we do for the domain. If you're a highlighter person, we like to go ahead and block off the left-hand side, block off the right-hand side, and make sure that all x values on that graph are in between those two bars. And then we're going to go ahead and state what two x coordinates those are between. And so it looks like we got negative 1, 2, 3, 4, 5, 6, 7, 8. So this is negative 8. And 1, 2, 3, 4, 5, 6. So I would say our domain is negative 8, comma 6. It hits every single x value from negative 8 to 6. And no open circles, no arrows for infinity. And so I'm going to go ahead and say that those are going to be square brackets. Okay. For our range, we're going to do the same thing. We're going to block off our top and bottom. And so the lowest this goes, to the highest it goes. Okay. All right. And then we're going to go ahead and get our y values. So down below, that's negative 1, 2, 3, 4. So this is negative 4. And 1, 2, 3, 4, 5, 6, 7, 8. All right, so we go from negative 4 to 8. Okay? And again, no open circles, no infinity, so we're going to use square brackets. Okay. All right, part B says to state the y-intercept of the function, and that's when the graph hits the y-axis, and that's that point right there, which is positive 2. Okay. Part C says state the x-intercepts of the function. And the x-intercepts are going to go ahead and be one right here on the x-axis. And there's another one right here on the x-axis. Okay. Functions are only allowed to have one y-intercept, but functions can have multiple x-intercepts in order for it to still pass the vertical line test. Right? All right, so this one, negative 1, 2, 3, 4, 5, 6. So this one's at negative 6. 1, 2, 3, 4. This one's at 4. Okay, so our x-intercepts, we have 2 of them. So we like to sometimes use squiggly parentheses and put them in there in numerical order, which one of them is negative 4 and the other one is 4. Okay. Also, guys, I don't know if we talked about this yet, but x-intercepts are called many things. They used to be very popular with calling them roots. Okay. And then they switched lately to zeros. Those are the zeros of the function. Okay. They also call them solutions. All right, just so you know. But zeros is actually the most popular one right now. Okay. If they ask what the zeros of the function are, they're talking about the x-intercepts. All right, so part D says identify the intervals f of x is increasing. So this is where we use our highlighter again, okay? And we're going to go ahead and start on the left-hand side of the graph like usual, and we are going up, and so that's increasing. Okay? However, then it stops and turns around and starts decreasing. And then it stops and turns around, and we're increasing. And then we are decreasing. And then we are increasing once more just for a little bit. Okay. And so they want to know our increasing, and our increasing are the red highlighted ones that we did. Okay. So we're going to go ahead and state those. Remember, they're always x values and they're always round parentheses. Okay. So the x value here is when we start is at negative 8. And that red highlighted piece goes all the way up until this x value here, which is at negative 4. Okay, always round. And then we have another piece. Okay? And this x value looks like it's at negative 1. And it increases up until here, which is at positive 2. And we have one tiny little piece left, and that looks like it starts increasing right around 5. and stops increasing at 6. Okay, and so those are the 3 intervals that our graph is increasing over. Okay, all right, so then part E. And part E says give the interval over which f of x is greater than 0. And we actually are cutting that out of our curriculum this year. So we are going to go right to F, and it says state any relative maximum or relative minimums. Okay, so remember, relatives are turning points and only turning points. So let's go ahead with the maximum points first. And we have a relatively high point here and a relatively high point here. Okay, relatively high turning point. So this one, it looks like it has coordinates of -4, 1, 2, 3, 4, 5, 6, 6. Okay, and again, I'm using round parentheses because this is a coordinate. Coordinates are always round parentheses. Think back to geometry. Okay, and my other relatively high turning point is at 2. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and those are my relative maxes. And they also wanted the. All right, sorry again, my 3-year-old is quite needy. And so now, guys, we're looking for our relative minimums. And remember, they have to be turning points for relative. So we need a relatively low turning point, which one is right here. And we have one more right here. Okay, so we're going to go ahead and say relative min. And the coordinates would be -1, comma 1. And our other one looks like to be at 5, comma -2. Okay. All right, we got one last part to do, and it says state any maximum or minimum. And remember, when we do maximum and minimum, it's just the y value, okay? Whereas the relatives are the whole coordinate. So we're going to go ahead and say max. What is the absolute highest point on our graph? And it looks like this point up here is, and that is at 8. Okay. Whereas our min is our absolute lowest y value, and that seems to be down here, which is at -4. And this one is all finished. Okay. All right, I will see you guys on the next question as soon as we scroll down. And here is number 2. It says, consider the function g of x equals 2 absolute value of x minus 1 minus 8 defined over the domain from -4 to 7. And so what that means is that we're going to have to grab our calculators and go to y equals. Once we are in y equals, we're going to type in 2. And then we need our absolute value bars. Okay, so we're going to hit second and our 0. And that gives us our catalog, and ABS is our absolute value. It's the very first thing, so we're going to hit enter. Okay. Inside those absolute value bars, we're going to type in x minus 1, and then we're going to arrow over so we're outside of the bar so we can type -8. Okay. Then we're going to hit second graph, or you can hit graph if you want a picture, but more importantly, we're going to create our own picture on our graph. They told us the interval that they want us to graph this over, and it's from -4 to 7. So -4, -5, -6. Oops, we're going the wrong way. -4, -3. Let's erase that. We could keep -4 if you want. It doesn't matter. All right. Let's try that again. Let's go in the right direction, not head towards -7. We want to head towards +7. So -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, and 7. Okay? Now, they didn't say we had to hit every number within there, but we definitely had to hit -4, and we definitely had to hit 7. Maybe we could have skipped a few in there if we wanted to. But here we go. So -4 is going to go with +2. -3 goes with 0. And then we're at -2. -1 goes with -4. 0 goes with -6. 1 goes with negative 8. And then negative 6 again with 2. 3 goes with negative 4. Positive 4 goes with negative 2. 5 goes with 0. 6 goes with 2. And 7 goes with 4. And now we're going to graph them. So we're going to put a dot at negative 4, positive 2, negative 3, 0, negative 2, negative 2, negative 1, negative 4, 0, negative 6, 1, negative 8, 2, negative 6, 3, negative 4, 4, negative 2, 5, 0, 6, 2, and 7, 4. Okay. If I had a straight edge, I would use one. However, there's not one in this program, so I'm going to try to draw my best straight lines. And one thing we should talk about is that there's not going to be any arrows on here. When they give you this interval, no arrows. They want you to start at negative 4 and stop at 7. If you put arrows, it means you're going past negative 4 and 7, and that is not what that interval means. Okay, so no arrows on this graph. And so part A is finished. In part B, they want you to state the interval over which this function is decreasing. So we're going to use our highlighters, okay? And we're going to go ahead and read it from left to right. And as we are on the left-hand side, we are going down. And down, remember, is decreasing. Okay? And then we turn and we go back up. And so that up part would be our increasing. Okay? It seems to looks like that they only want the decreasing part. And remember, it's x values. And our x value starts here, which is at negative 1, 2, 3, 4. So negative 4, comma. It looks like it stops decreasing at this x value here, which would be positive 1. And again, with increasing and decreasing, it's always round parentheses. Okay. Part C. It says identify the zeros of this function. And we talked about that in the last question, that zeros are the same thing as our roots, which are the same thing as our x-intercepts. And we said that graphs that are functions can have multiple x-intercepts. Okay? This one seems to have one right here, which is at negative 3. And 1, 2, 3, 4, 5. One right here, which is at 5. Okay, so we go ahead and say that x equals negative 3, comma, 5. Okay. Part D, we're going to go ahead and skip, cut that one out. And we're going to go right to E, and it says identify any relative max. Okay, so remember, relatives are turning points, and there are no relatively high turning points. And so we're going to go ahead and say none. We have 2 endpoints that are high, but they're not turning points, and so we cannot classify them as relatives. Okay. Relative min, we do have a turning point that is relatively low. Actually, it is the lowest, okay, but it is still relative. And the lowest that goes is at negative 8. So the coordinates are 1, negative 8. Okay. Your max is your highest point, and it doesn't have to be a turning point. And so we're going to say at the highest that this graph goes looks to be like 1, 2, 3, 4. And the lowest it goes is negative 8. Okay. And there are our answers. Okay. So we'll see you guys on the back side of notes for the last part of it.